Good morning, good afternoon, or good evening, whatever time you're watching this educational video. We'll be solving problems related to capacitance. Capacitance, the symbol that we will be using to represent the variable capacitance is caps lock C. Don't be confused with this symbol to our unit coulombs because coulombs is a unit itself for charge and capacitance or caps lock C is used as a variable. Okay? When we say capacitance, it is the main property of a capacitor. I will be showing to you later what a capacitor look like. And it will just describe or it will just give us the quantity or the magnitude or value of the stored charge in capacitor per voltage. And the unit is farad or F, or we can also write it down as coulombs per volt. Okay, and again, it will just describe the stored charge per voltage. So we can have this formula. Again, the caps lock C, that's capacitance, and then you will have the stored charge in a capacitor over voltage. So this is a very simple formula to get or to figure out the capacitance. Question, what is the direct variation between capacitance and charge? So by this formula provided a while ago, you'll try to rearrange it to, to know the relationship or the direct variation between capacitance and charge if volt is constant. So we can just cross multiply this equation, Q times 1, and we have capacitance times delta volts. So we can have this charge is equal to capacitance multiplied by the delta volts. So if you can see, if voltage is constant, what's the direct variation between charge and capacitance? It's very clear that they are directly proportional. Okay, meaning to say, if you have a high capacitance or high farads, means it can store more charge, and on the other hand, if you have low farads or low capacitance, means less charge is stored in that capacitor. And this is just like a North Star that you need to recall, or the North Stars. Charge is stored in the plates of a capacitor. I will be showing to you later. And the electric potential energy or the energy is stored in the E field this uh, between the plate of the capacitor. Again, plate of the capacitors. Since these plates are charged, therefore they can generate E field or electric field. This is a very simple problem. It's the capacitor. It's a very tiny electrical component, and it's there are values here like 40 microfarads, and we have 12 volts. That's how it looks like. Okay, and let's determine the amount of coulombs. When we say coulombs, it's just the unit of our charge. So we will find the magnitude of charge or coulombs that this capacitor contain, okay, or can store. And remember, you have 40 microfarad here, and 1 microfarad is equivalent to 1 times 10 raised to negative 6 farad. Okay, please take note. And 40 microfarad from the unit, if you will just be focusing on the unit of capacitance is farad, so this will be our capacitance. And of course, this will going to be our volts. And to get the amount of coulombs or charge, we can use this formula. We have charge here equals capacitance times the change in voltage. So we can use this formula to figure out the amount of coulombs or charge. So let's substitute perfectly. So 4 times 10 raised to negative 5 farad. That's 40, 40 uh, times 40 times 1 times 10 raised to negative 6. Sorry for my penmanship. Negative 6 farad. We just converted the microfarad into farad. So you will come up with this product. It's 4 times 10 raised to negative 5 farad. It's already in farad. And then we will just multiply it by the change in volts. So you will have 12 minus 0, so you can have 12 volts, okay? And you will have this answer. 4.8 times 10 raised to negative 4 coulombs. And I'm going to show you why coulombs is the unit. Of course, we knew it already that the unit of charge is coulomb, but we have farad and a voltage here. So when we multiply these units, remember farad could be written as coulombs per volt. So, by the way, if we will use the sig fig when we multiply capacitance and voltage in our problem, we have two sig fig here and we have one sig fig. When uh, we multiply and we use the sig fig rule or the significant figure rule, uh, we will just have to follow the least limiting factor. So we have one sig fig here as the least. So our final answer should have one sig fig. So one five is 5 times 10 raised to negative 4. It's it's, it's one sig fig. So this is going to be the answer if sig fig is applied. Going back to the unit, why coulombs is our unit here? Obviously, it should be coulombs. So we can have it this way. If we multiply farad, farad could be written as coulombs per volts. Remember, farad or coulombs for volts per volt. And then we can cancel out the volts here and the other volts here, and we have our coulomb as the remaining unit. So that's the answer. Okay. And next problem, uh, another problem if inside the capacitor, we will be looking on what's inside the capacitor. So it has two oppositely charged plates. I will be showing to you later. And varying area, it could be circle or square or triangle. It depends upon the problem. As long as you know what's the formula to get the area of these shapes. And yeah, they are separated by a distance sometimes, or mostly it's air or vacuum, or we have a dielectric inserted in between. We'll be discussing dielectric in our next topic, okay? And this is the capacitor. It's an, like an icon, but I know for sure you have an idea what it looks like in your gadgets or inside your, if you will just open your dysfunctional television. So you can have a lot of capacitors there. The main function of capacitors is to store charge and release it. Okay. Now, if we will try to look at it, what's inside, it looks like this. This is our M, or it's another way to say, uh, if yeah, M is another word for battery, and it's electromotive force. This is the force that will push the electrons in this wire. This is the wire connected to the uh, plates of the capacitor. This is what we call the plate, by the way. Okay, the plate of a capacitor, they have the same area. It depends upon the shape. And then the one that is connected to this negative terminal of the battery, it will have a lot of negatives there, making it negatively charged plate of the capacitor. And then this is the positive side of our battery or amp. Uh, the plate is being connected to the positive will have many positives charge, okay, or many positive charges. So making it a positively charged plate. So they are oppositely charged and they have distance in between them. Okay. If you look at the symbol of our M or battery, one is longer and the other one is shorter. Longer line means the positive terminal of the battery or the M, and then the shorter will be the negative, okay? Negative terminal of the uh, M, and then connected to the wire leading to a plate. Since it's connected to the negative, so it will have a negative, a lot of negatives. On the other hand, a plate connected to positive will have a lot of positives, okay? And the distance. If the problem wants you to figure out the capacitance in this uh, provided picture, we have another formula for that, derived formula to get the capacitance. We will not be using this because we don't have distance in our variable, and we don't have like area. Please be careful. We're looking at the area of this circle here, not the cylinder, not the cylinder. Okay, it's the area of this circle here. Okay. Now I will be introducing this new formula, derived formula from our electric field, and then we come up with this another formula for capacitance. If area is given, this is area A of a certain shape. In this case, we will be dealing with circle. And then the distance in between these plates, it's provided also in the illustration. It's 0.003 meter. It should be in meter. So yeah, we have no problem with it because it's already in meter. Okay. And if you notice, the capacitance is directly proportional with the plate area. If you can see capacitance and the area, if you have large area, of course, there will be more charge to store. So your capacitance will go up, right? Okay. If you have larger area, it will go up. If you have like smaller area, so your capacitance will also be like lower because it can just store little amount of charge. Okay. And if you look at the relationship of capacitance and distance, they are inversely proportional. Okay. When these plates are closer to each other, very close, so it will have a shorter distance in between, so the capacitance will be like high. And when you will move these plates away from each other, longer distance, so it's inversely proportional, so the capacitance will go down. Okay, you can definitely read the formula that way if they asked you, if the problem or the question asked you about the direct variations between these particles here. And we know already this figure here. It's the epsilon naught or the permittivity of free space. This is our uh, value. It's constant. In vacuum, it's 8.854 times 10 raised to negative 12 farad per meter. In other books, in other reference, they will just round it off to 9. Okay, but in this class, we will be using this figure. So let's have the problem. It can be, guided with these formulas here, which one to use. But for sure, we will not be using this. We can also use it, but it's better to use this one when we are uh, figuring out the charge. Okay, it's easier than this. Okay, it will save time. The question is determine the initial capacitance and charge. Okay, and in our problem, it's there the epsilon naught in a vacuum. It's provided. We have 12 volts or battery and connected to these plates. And we have a radius because we will be dealing with the area of the circle later. So it's 0.3 meters. It's already in meters, so yeah, it's good. And we have a distance in between this plate. It's already in meters also, 0.003. And yeah, we can solve for the capacitance using this formula because we have the area of a circle. We can solve it because we have the radius here. We know the epsilon naught and we know the distance in between plates. So we can use that formula and the area of circle, not cylinder, but it's circle, okay? Not a cylinder. So, because we will be dealing with the area, not the surface area. It's just the area of the circle. Okay, and it's pi r squared. So just substitute the radius in this formula. 3.14, the value of pi multiplied by 0.3 squared, you will get this value here. We can substitute this value to our area. Okay, we have it here. We plug in the epsilon naught and then the area of a circle that we just computed earlier, seconds ago, and then we have the distance in between plates. That's 0.003 meters. And yeah, we can cancel out this unit here, 1 meter, and then another 1 meter from meter squared, and we can still cancel meter, and then this remaining meter here, and then we have the farad as our remaining unit. It makes sense because capacitance unit is farad. If you will plug in all these values in your calculator, it will give you this answer. It's 8.340468 times 10 raised to negative 10 farad. Or if you will apply the sig fig rule, you look at the numbers here, we divide certain numbers so we can we have to follow the least limiting factor. So this is, we have 1, 2, 3, 4 sig figs. In this case, we also have 4 sig figs, and then this one we only have 1 sig fig. Least limiting factor is 1, so we have to uh, polish our answer with 1 sig fig. So we can have 8 since we cannot round it off. 3 is the number next to it. So 8 times 10 raised to negative 10 farad. That's if we will follow the sig fig. Now we want to know about the initial charge. Okay, we put I here to represent the initial capacitance and initial charge. We will be using this formula because it's easier than this. We can just divide it, we can just multiply capacitance and the voltage. In our figure, we have 12 volts. Okay, that will be the value of P or volts in our equation. And the capacitance here, we will just be using the sig fig because it has new figures. Okay, so we will be substituting this value in our capacitance and 12 volts in our change in volts. So that's it. 8 times 10 raised to negative 6 farad and then 12 volts. So we can have 9.6 times 10 raised to negative 10 coulombs. And I already like you, I showed it to you how it arrives to coulombs when you multiply farad and volts. Okay. And since we have like we multiply numbers. If we will apply sig fig here, this is 2 sig figs, this is 1 sig fig. And we can polish our answer to like 10 because we can round it off. 10 times 10 uh, raised to negative 10 coulombs. Okay. And then here, it's 1 sig fig. So yeah, makes sense. Next question is, if the distance is tripled, what will be the new capacitance and the charge? We all know if we will separate our plates away from each other in a longer distance, our yeah, let's say longer distance, our capacitance will become lower. So let's try to compare it later. Still, we will be using this formula. We already computed the area of the circle. But this time our distance is being tripled. So we just have to do it like this, times 3. So you can have this value that you can substitute in your distance. In in the distance of our equation. So we will plug in the epsilon naught. It's constant. We already calculated the area of the circle, but this time we have our new distance, tripled distance. So we increase the distance, so for sure we will have a lesser capacitance this time. This time. And if you will plug in all these magnitudes in your calculator, it will give you this figure, many figures, right? So you can just make it in a, like we can polish it by using sig fig. We have like four sig figs here in our area. We have four sig figs in our epsilon naught. We have one sig fig. And this will be the least limiting factor, so we can rearrange or polish it, not rearrange. And remember, it's 7 next to 2. So we can just add 1 to 2. So you can have 3 times 10 raised to negative 10 farad if we apply sig fig. That's the new, I'd say, final capacitance. And the final charge or the new charge, of course, since it's like getting away, the plates are getting away, so the capacitance becomes lesser, so it can store lesser charge. We will expect that to happen. So we will substitute this sig fig uh, based answer to our capacitance and then multiplied by still 12 volts. And substitute it here. It's 3 times 10 raised to negative 10 farads. You just follow this answer here, following the Sigfrid rule, and multiplied by 12. So you can have um, 3 times 3.6 times 10 raised to negative 9 coulombs. And if you will apply the sig fig here, 2 sig fig, and then we have 3 as 1 sig fig. It's the least limiting factor, so we can have 4 times 10 raised to negative 9 coulombs. So that's going to be our answer if we will be using sig fig. Okay? And yeah, that's it for this moment. Thank you so much for watching, and I hope that it will help you in your review. And yeah, you can like, share, or you can subscribe to this channel if you like. That's it for this moment, and see you around till next time. Bye for now.